Hi, welcome to QuBites, your bite-sized pieces of quantum computing. My name is Rene from Valorem Reply, and today we're going to talk about quantum-inspired optimization. And I'm very honored to have a special guest today here with us, our expert Marco. Ciao, Marco. How are you doing?
Ciao Rene, very good. Thank you very much for inviting me.
Yeah, and thank you for sending me over the aperitif kit. So I got a little nice package with this great card in here, and I got a bunch of, well, aperitifs. So thanks for sending it over. Cheers, my friend.
Cheers.
Cheers. And can you tell us a little bit about yourself and your background as it relates to quantum computing?
Yes, very briefly, I got a degree in physics and a PhD in quantum engineering. And in the last 20 years, I've worked in IT consulting, information technology, and the last 3 years, I've worked on quantum computing for Reply.
Awesome. That's quite impressive. So you're the right expert to tell us what is actually quantum-inspired optimization.
Yes, that is a very new field, applied field, in which you use quantum algorithms to find the optimal solution in a lot of problems. A very easy problem to understand is when you have to pack a lot of dishes in your dishwashing machine. You want to pack their dishes, the glasses. It's not so easy. Then you find a solution. You just put them, you stuff inside. But you can find a better way, an optimal way. And the computers, like quantum computers, they are very good in finding that optimal ways. So this is a new field. And I hope this explain a bit this kind of field.
Well, I can't wait until we have quantum computing dishwashers. I mean, that's just a challenge we have to, like, every one of us has to face every day, pretty much, right? So that's awesome. And what are some of the typical optimization problems you see as well with other clients? Like, you typically have an optimization problem, like you mentioned, like packing a dishwasher, or it could be like a cost saving, or in the end, you want to reduce the energy you put into the system in the end, right? And maximize the output. And
Yeah.
And you can run that with quantum-inspired optimization. You can actually develop an algorithm that is designed with quantum computing in mind. So it can run on quantum computers, but it can even run on classical hardware, right? And so you're already seeing that these quantum-inspired optimization algorithms are outpacing your classical state-of-the-art optimization algorithms, even on classical hardware, right?
Yes, we are seeing this kind of scenario where you can run on classical hardware, and we are seeing a lot of real world use cases. We are among the 5 finalists of the Quantum Airbus Challenge as Reply,
Yeah,
in
nice.
where you want to pack the more stuff that you can inside an airplane for transporting goods. So, there is a lot of such kind of real world problems. Another project, real project that we have done is for optimizing the tour that you have to do for your workforce when you want to make maintenance of energy lines. So you have to do a lot of things in different places, and you want to travel the less and work the more.
Right.
And this kind of problems, it seems strange, but they are very difficult to solve.
Yeah.
And you solve with an approximate way. But if you solve it better, you save money. You transport more goods, or you travel less kilometers, you do less pollution, you use less gasoline. So that is the thing. And you can run on CPUs, GPUs, QPUs.
Nice. So you can take these advanced algorithms designed for quantum computing, run it on classical hardware, like an array of GPUs, which are optimized for, you know, computing a lot of matrices. And so you can take advantage of that and run that. That is pretty amazing. And one of the problems you described sounds like the classical traveling salesman problem, kind of, right? Which is this NP complex problem in computer science. And I know that one algorithm is gaining a lot of attention these days. It's called QUBO, right? Which is, what is it actually, and why is it better than classical optimization algorithms?
QUBO, it stands for quadratic unconstrained binary optimization. You know, at the end of the day, you model your problem in a quadratic way. So this modeling, it is much better, more flexible, and more adaptable to real-world problems instead of linear programming. So you have a lot of real-world problems that they are better modeled by QUBO, by quadratic, and moreover, with this modeling, you can run very fast on GPUs, because GPUs, they do matrix multiplications. Yeah. And in quadratic models, you have a lot of matrix multiplications. We have studied this in depth in the last 3 years. We have published a scientific paper on Springer Quantum Machine Intelligence, a peer-reviewed journal. And we have done 5 projects, and we have seen that this is the real world. So we are in production, we are delivering value to customers with this kind of approach.
That is awesome. And in the next episode, we will actually talk much more about the impact you're already seeing today with some client projects. And so I think that's great to hear about, like quantum inspired optimization, QUBO. I think we all understand now what it is. And so thanks for joining us. We're already at the end of the show. Thanks so much for providing your insights and joining us today. Very much appreciated. And thanks everyone for joining us for another episode of QuBites. Watch our blog, follow our social media channels to hear all about the next episodes. Take care, be safe, and see you soon. Bye-bye.
Thank you very much, everybody. Bye-bye.